You know that feeling when your phone's auto caption just completely butchers what you said? It might be more than just a simple funny glitch. Today, we're going to dive into the hidden biases in AI and how they can have some pretty serious real-world consequences.
So let's start with a story that I bet sounds familiar. You're recording a quick voice message, right? But the automatic transcription comes back as just a total jumble of nonsense. It makes you sound like you can't even speak clearly.
Okay, now imagine that exact same thing, but it's happening on a really important work call. The auto transcription is just riddled with errors, and it makes you sound unprofessional, maybe even hesitant. And all of a sudden, you're the one who has to explain that, hey, it's the system that's messed up, not me.
See, these aren't just random, annoying glitches. No, they point to something much, much bigger. Uneven error equals uneven risk. It's simple, really. When an AI makes more mistakes for some people than it does for others, the consequences are absolutely not felt equally.
So what's the deal? If nobody is sitting there, programming these things to be biased on purpose, where is it all coming from? Well, let's dig in and find out.
There's this common idea that machines are fair, right? They don't have emotions, so they must be objective. But is that really true?
Well, here's the thing. An AI model is basically a mirror of the data we train it on. And that data, it's a product of our history, with all its flaws and all its biases. If our history is full of inequality, the AI is going to learn those exact same patterns. Sometimes, it even makes them worse.
And this bias, it's not like one single bug you can just find and squash. Nope. It kind of seeps into the system from three main places.
We're going to look at the raw data itself, the labels that humans put on that data, and even the ultimate goal the whole system is trying to achieve.
Okay, so first up, the data. Think of it like this. If a certain group of people isn't well represented in the training data, the AI is just going to be less accurate for them. It's like trying to navigate a city using a map that has a huge blank spot right where your neighborhood is supposed to be.
Next up, the labels. See, AI often learns by looking at decisions that humans have already made. So if, historically, hiring decisions or loan applications were full of human bias, guess what? The AI learns that bias as the correct way to do things. It's basically automating old prejudices.
And finally, get this, even if you had perfectly balanced data, the AI's goal can still create bias. Let's say a system is designed just to get as many ad clicks as possible. It might figure out that the easiest path to that goal is by targeting vulnerable people with really manipulative stuff. The goal itself creates the problem.
Okay, so let's see how all this stuff builds up into one of the sneakiest traps in AI fairness, what I call the average illusion.
Now you might be thinking, hold on, don't companies test for accuracy? And yeah, they do. But it's how they report the results that can be super misleading.
So you'll see a report, and it'll boast this big, impressive number, right? Our system has 95% accuracy. It sounds fantastic. Makes you feel like, great, this thing works for pretty much everyone. But that is definitely not the whole story. Because that really impressive average can be hiding a seriously troubling reality. You break it down, and you might find it's 99% accurate for one group, but a dismal 70% for another. That good average totally papers over the fact that the system is failing an entire community of people. There's a great way to think about this. Average accuracy is like the average temperature in a hospital. It might be fine on average, but that's not much comfort to the person in the ICU with a sky-high fever. A good average can hide a life-or-death problem.
Okay, so if we know this is a problem, why not just fix it? Why can't we just program the AI to be fair? Well, as it turns out, it is way more complicated than that.
And here's why. Fairness isn't a technical setting you can just toggle on. It's a deeply human concept. To make an AI fair, you first have to make a choice, a really tough choice, about what kind of fairness you're even talking about. For instance, are you trying to give every single person an equal shot, or are you aiming for equal outcomes across different groups? Or maybe you want to make sure the error rate is the same for everybody. The really tricky part is you can't have all of these at once. Often, when you try to improve one kind of fairness, you actually make another one worse. It's a trade-off.
So given all that, what do we do? What do the responsible teams do? And what are the big red flags we should all be looking out for? Well, the teams that get this right usually do 4 key things. 1, they work to fix and balance their data. 2, they test performance for specific groups, not just the overall average.
3, they actually set limits, guardrails, to stop bias from getting out of hand. And 4, for high-stakes decisions, they always make sure there's a human in the loop and a clear way for people to appeal a decision.
So here's what you should be skeptical of. If a company only shows you that overall accuracy number, that's a red flag. If there's no way to get a human to review a decision made by an algorithm, huge red flag. And if nobody is checking for new biases after the system gets an update, yeah, that's another big reason to be concerned.
And really, this is the bottom line. Fairness isn't some technical default setting. It's not something that just happens. It is an ongoing commitment, a series of very deliberate policy choices about our goals, our data, and the trade-offs we're willing to make. And that leaves us with one last, really important question. If we manage to make a system fair today, how on earth do we make sure an update won't break it tomorrow? As this technology just keeps changing and evolving, how do we guarantee that all that hard work doesn't just get erased? That's the question we all need to keep asking.